Today, devices are becoming smarter. Your earphone, your camera, and even your washing machine, they are becoming smart. And even without connecting to the internet. This is Edge AI or embedded AI. So let's understand what is Edge AI from basics. Most people think AI needs powerful servers and huge GPUs. But today, AI can run on tiny chips that consume less power than an LED bulb. In traditional AI workflow, your device collects data like audio, video samples, or sensor reading and send that data to the server where actual GPU is there and inference is done over there. And it returns the output data to the device. And this cycle is called inference cycle. But there is problem because of it. First, it requires internet, and second, it's time consuming, and third, uh, privacy. Your data is not private anymore because it's leaving your device and going to the cloud. Now, Edge AI solved this problem. It solves by running the inference directly on the device itself, like on the microcontroller. Think of the workflow like this. First, data capture. Your device collects data from sensors like camera, microphone, or accelerometers. Second, processing. The raw signals that being captured by your device now being cleaned, resized, or normalized. Like for example, the captured images are being converted to grayscale, or the captured voice sample is being converted to a spectrogram. Third, inference. Now here in that device, a neural network is running it's like producing some kind of predictions based on the captured data. And fourth, action. Now based on the prediction, whatever that neural network takes because of the data, certain actions are being taken, like for example, unlocking your phone, turning on light, or detecting some kind of defect in the conveyor belt, or raising some kind of errors. So this is called on-device inference. But how do big AI models could fit in tiny hardwares with so much of constraints like memory or processing power? This is where the real engineering begins. Originally, the neural networks are quite big and requires a GPU to be trained. But after training, in order to run them on small chips like embedded system or microcontrollers, we use several techniques like model quantization. So we decrease the precision of number from 32-bit to 8-bit. Second, pruning. Now we remove the unnecessary neurons or weights from the network. Third, knowledge distillation. So we are compressing the big models in a smaller one. So after using these types of techniques, the model becomes that much smaller that we can deploy them on the edge devices. After these steps and techniques, the model becomes so much smaller that it can be fit in a low power microcontrollers like ARM Cortex-M or edge SoCs like Qualcomm Snapdragon or NVIDIA Jetson or Google TPU. The optimized model is then deployed in hardware for real-time inference. There are two main categories of edge AI hardware. First is microcontrollers. They are very power efficient and use very low power. And their example use would be smart door lock, or IoT sensors, or wearable devices. And second is edge SoCs. They are single board computers or accelerators. Now they had very high compute power and can be used in places like in drones, robotics, or self-driving cars, etc. Edge SoCs uses specialized engines like NPU, DSP, TPUs or GPUs in order to make the inference faster and more efficient. Why this edge AI or embedded AI important? First, because it's fast, as inference is directly run on that device. Second, it protects privacy. Now, data never leaves your device. And third would be cost effective. As cost, we're not dependent on continuous server billing. And fourth will be it works offline, as it doesn't require any sort of network or internet in order to send the collected data for inference, as the inference is directly running on the device. Now, because of all these reasons, companies are pushing AI into healthcare devices, industrial automation, smart agricultural systems, or agricultural drones, or smart home applications, are like security cameras and security systems and etc. applications. So this is a growing field. I thought like it will be nice to make a video of it. And thanks for watching, and don't forget to like the video. Bye.